Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 1.4.2 homework solutions on solving systems of linear equations. For this first problem, let me label my system of three equations here. Now, looking for things that I could cancel out by adding them together, it looks like equations 1 and 2 are pretty similar. I'm thinking if I just made one of these negative and added them, that would make some good things happen. So let me do that. Let me do E1 plus negative 1 times E2, or E1 minus E2. So E1, I'll cut and paste that there. And E2, let me just negate all of the things in there. So negative x, negative y, and positive z equals 0. So adding these together, the x's are going to cancel, and actually so are the z's. So we end up with, this is going to be 2y equals 2 plus 0 is 2. So right off the bat, dividing by 2 here, we get one of our variables, y equals 1, right off the bat. That's pretty cool. Now that we've got one of those variables, we can actually plug it back in to pare some of these equations down a little bit. So let me plug this back into equation 1. So I'm going to have x plus 3 times 1 minus z equals 2. So let's see here. We've got 3 that we can subtract over to the other side. So that's x minus z equals negative 1. And I'm going to call that equation 4. So that's one of those two variable equations. And then let me go ahead and plug this into equation 2 while I'm at it. So we've got 1 plus, or actually x plus 1 minus z equals 0. And then subtracting 1 over to the other side, we have x minus z equals negative 1. All right, so let's call that E5. So these are my two equations now that I can play off of each other. If I multiply this E5 by negative 1 and add these together, that should cancel some things out. So let me next do E4 minus E5. E4, just cut and paste that there. And E5, we're negating all of this now. So negative x plus z equals positive 1. And adding all this together, x's go away. Z's go away, and the 1's go away as well, honestly. So we have 0 equals 0. This is one of those situations where you get a number equaling itself at any point. This is an indication that you have infinite solutions for this system. On this problem, before we go ahead and start adding equations together willy-nilly, it's good to see that we actually already have one of our values, z equals 5. So let's actually just substitute that into equation 2 here, which I've labeled, just to see if we can get a y value back. So subbing that into equation 2, we have y plus 2 times 5 equals 13. So that's basically y plus 10. Subtracting 10 over there gives us y equals 3. And right away, we've got two variables in rapid succession. So I'm just going to take these two variables. We know that z is 5 and y is 3, and plug those into this first equation where I also have that x that I can now solve for. So this is basically just substitution method, quick and easy. So we have 2 times x minus 3 times 3 plus the z value 5 equals 10. So this is negative 9 plus 5 is negative 4. Adding 4 to the other side gives us 14. And then dividing by 2, we have x equals 7. So putting it all together, we have 7, 3, 5. On this next problem, everything here is in standard form, so I'm probably going to go the elimination route. Is there anything that would be pretty easy to get rid of? Which variables here? I'm thinking y's are a good target because I have a negative 1, a negative 2, a negative 1, so those are pretty easy to match up. So let me start. If I multiply this first equation, which I'm going to call E1 and E2 and E3 for the other ones, if I multiply this first one by negative 2, that gives me a positive 2y, which would cancel with this negative 2y. So let me do negative 2 times E1 plus E2, just to start things off here. So that's going to be negative 6, positive 2y as expected, negative 4z, and negative 8. And then just copy and paste equation 2 right over there. So the x's cancel. I wasn't trying to cancel those, but they did. Okay, the y's cancel. The z's cancel as well. So we have 0 left over on the left side. We have negative 16 on the right side, which does not equal 0. So because we have two numbers that don't equal each other and no letters left, this tells us that there is no solution to this system of equations. The good news is that means we're done with this problem. For this final homework problem, what better boss battle is there than a word problem? And if you're hungry for knowledge, this one's for you because this is all about a pizza shop. So we have 2 small pizzas, a liter of soda, and a salad costing $14, and they've got some other arrangements as well, giving different combinations adding up to different dollar amounts. Based off of this, we're going to see how much each item costs individually, because apparently they don't have a menu display. They just kind of charge you when you come up to the register with these items. But it'd be nice to know why you're paying what you're paying. So let's come up with 3 equations because there's 3 different variables to solve for. And also while we're at it, let's come up with some letters to represent different quantities. So we have the amount of pizzas. Actually, we have the cost of a pizza, the cost of a soda, and the cost of a salad. I'm going to let X represent the pizza price. I'll have Y be my soda price, and Z will be the price of a salad. So just taking a look at each of the 3 sets of information they gave us. We had 2 small pizzas, so I'll call that 2X, plus a liter of soda, so plus Y, 1Y, plus a salad, so plus Z, equals $14. And we're going to use a similar setup for the other 2 here. So we have 1 small pizza, so X, plus a liter of soda, plus Y, and 3 salads, that's a plus 3Z, equals $15. And then finally, the last set, we have 3 pizzas, so 3X, a liter of soda, still have a plus Y there. Apparently no one wants more than a liter of soda. It's probably better off that way anyway. And then we have 2 salads, plus 2Z, costs $22, so 22. All right, and I'm going to label each of these equations E1, E2, E3, corresponding to my 3 orders at this pizza shop. So in terms of variables that I can eliminate, they're all going to be pretty easy, but I think Y is the easiest of all. They're literally all 1Y. So I just need to take one of these equations, multiply it by -1, and add it to the other ones. So just to start this off, I have to start somewhere. I'm going to go with E1 plus negative E2, or E1 minus E2. So E1 I'm just going to cut and paste as is. E2 I'm going to negate all of this, so multiply it by -1. So negative X minus Y minus 3Z equals -15. And then adding these together, my Y's are canceling. We have 1X, and then this is going to be Z plus -3Z is -2Z, all of that equaling -1. I'm going to do something pretty similar, and I'm going to call this equation, by the way, equation 4. There we go. I'm going to do something similar with equations 1 and 3 now. I'm just going to do E1 minus E3. So same idea, just a different second equation. E1, again, I'll cut and paste that one. That one's staying the same. E3, I'm negating all of these now. So -3x minus y minus 2z equals -22. And then adding these together, y's are gone, and we have -x, and this will be a -1z equaling a -8. And that's equation 5, I'll call that. Now here's my 2 new equations that each have the same 2 variables. I'm going to play these off of each other. If I add them together right away, will anything cancel? Actually, it will. The x's are going away. So let me just do E4 plus E5. Hey, why not? So I'll just cut and paste E4 and E5 directly down here. Add those together. X's are gone. We have a -3z equals -9. And we see by doing this that z then must equal +3. So that's $3 for a salad. Okay, let's plug this back into one of these 2 variable equations now to figure out the x value. I'm thinking equation 4 looks a little nicer because it just has 1x instead of -1x. So let's go equation 4. So x minus 2 times 3 equals -1. That's x minus 6. And if I add 6 to the other side, I end up with $5. So pizza is going to be $5. And then finally, let's plug both of these back into one of our equations in the beginning. Although, actually, on second thought, if I'm trying to figure out y, yes, actually I do need to plug into one of them in the beginning. Because I know x, I know z, I need an equation that has both of these and also has a y in it. Let me just go with equation 1. Why not? So we've got 2 times pizza price of 5 plus y, that's what we're looking for, the soda price, plus the z value 3 equals 14. So this is 10 plus 3 is 13. And if I subtract 13 to the other side, I get y equals 1. So that's $1 for a soda. So I guess these seem like fairly reasonable prices, maybe for like, I don't know, 10 years ago. Maybe not so much today, but who knows? Maybe it's a discount place.